Hello, this is Mr. Knowles, and this is a second video about adding and subtracting fractions with unlike denominators. So if you watched the first video, this is just another one with some different types of fractions to work with. So let's get started. So number one, solve the following problem using a labeled sketch to explain your thinking. 3/10 plus 2/5. Alright, well, I'm looking at those denominators. They are definitely not the same. I have a 10 and I have a 5. I'm going to start with the 3/10. So I need to make 3/10. Remember, the bottom number, the denominator, tells me the size of my rectangle, the area of my rectangle. And the 3 on the top tells me how many I shade in. 3/10. And I'm going to add. I'm going to add 2/5. Well, if I do fifths, it would look like this, right? 2/5. But something's wrong with that picture. Maybe you already know. The rectangles are not the same size. So the first rule for adding, subtracting, and comparing fractions is that denominator, that rectangle in your picture, they have to be the same size with the same area, same number of squares that make up the rectangle. So I got to change things up a little bit. I have to have it look like the other one. The bottom number of the fraction, the fifths, tells me how many pieces it's broken up into. And the top number, the 2, tells me how many of those fifths I have. I have 2/5, so I'm actually going to shade in, draw circles inside, or eggs, in 2 of those 5 pieces. And I'm going to go ahead and I'm going to build, I like to call it an answer rectangle. That's exactly the same size. And now I just have to put the 3/10 and the 2/5 circles, shaded squares, eggs, all into one rectangle, or I like to say one basket, because that's what adding is. So I have 3/10, and then I have my 4 circles that were from the 2/5. And my answer is right there. So I have 1, 2, 3, 4, 5, 6, 7 tenths is my answer. 7 tenths. Let's look at 4/5 minus 3/10. Okay, first thing I notice is that it's a subtraction problem, so we gotta be careful with that. So let's go ahead and build 4/5, but you have to think of it comparing to 3/10. So someone might go ahead and do this. Someone might do this, which is what 4/5 is, but you're going to be subtracting a different fraction with a different denominator. You're going to be subtracting 3/10. And what you're going to notice is that those rectangles are not the same size yet. So you have to change one of them. Do you know which one to change? You have to change the first one, the 4/5, and make it tenths. So let's do that real quick. So be aware of that. Okay, now they're the same size. I'm going to cut them into fifths. And I'm going to shade in 4 of the 5 because that's what that fraction represents. There's 3/5, so I need one more. That's 4/5. So 4/5 is really telling me or showing me that it's the same as 8/10. Remember, we're subtracting. I'm going to make my answer rectangle here. And subtracting means I'm going to take 3 of these away from the one on the left. So I'm going to take away 1, 2, 3. So my answer is 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. I rearranged them for a reason. Do you know why? It's visually easier to see that my answer is half. So my answer is half. You could also say that your answer is 5/10. They're equivalent fractions to each other. Alright, third problem. 1/4 plus 2/5. 1/4 plus 2/5. This one's tricky because you have a 4 and a 5, and you need to find a rectangle that has an area for fourths, and then do the same thing for fifths, where the rectangle is the same, has the same area. So you have to think about this. I'm going to kind of lead you on here. 1/4. I'm going to use a rectangle with an area of 20. So it's going to be 4 by 5. That should have 20 squares in it. And I'm going to cut it up into 4 equal pieces. So that'd be 4 slices this way. And I'm going to shade in 1/4 of them. So what I did is I just made an equivalent fraction of 5/20. And it looks like we're adding. So we're adding. Now I have to build the same thing for 2/5. So same size rectangle, 4 by 5. Is that 4 by 5? It looks like it. So this is 2/5. Now I have to make this one into fifths, so I'm going to cut it this way. That'd be in 5 equal pieces, and I need to shade in 2 of those 5. There's 1/5. There's 2/5. So 2/5 is the same, it's equivalent to 8/20. Okay, I'm going to make my answer rectangle. I hope I have enough room. Has to be the same size as the other two. And now it's just a matter of putting both of those all in to the answer rectangle. So I got the one from the first one. And then I got to put 8 more from the second one, the 2/5 in here. So there's 3, 4, 5, 6, 7, 8. I'm going to move this one over here, make it look a little easier. And it appears that my answer is, if I were to count all of these, is it 13? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 20ths. Pretty interesting problem, I say. Alright, fourth problem. 2/5 minus 1/4. Okay, we got fifths and fourths again. So we're looking at a 4 by 5 rectangle. Correct? This is going to represent 2/5. So I need it in fifths. And I need 2 of those 5 sections. Colored in, shaded in. And what 2/5 means is 8/20. That's an equivalent fraction. We're subtracting. I'm going to build the second one. This is going to be 1/4. So I'm going to break this up into fourths. One of those 4 are colored in, shaded in, and it looks like 1/4 is 5/20. Don't forget, this is subtraction, so I'm going to take away this 5/20. 5 circles or shaded squares away from the first one. So I'm going to take away 5 of these. And I'm left with 1, 2, 3 20ths. So I'm left with 1, 2, 3 20ths. 3 20ths is my answer. You've been really patient working on these problems. I do have one more, so bear with me. Last one. Solve the following problem using a labeled sketch to explain your thinking. 2/3 plus 2/5. Thirds and fifths. Think of a number that 3 and 5 go into, and the one that comes to mind is 15. So I'm going to make something that's 3, well, not something, I'm making a rectangle that's 3 by 5. And this is going to represent 2/3. So I need to break that up into 3 equal parts. I guess I'll go this way. And then 2 of those 3 parts are shaded in, or you can draw circles or eggs. And we're adding. So we're going to add 2/5. So let's break this up into fifths. And we're going to shade in 2 of those 5. So just looking at those, the first one, the 2/3, is really it's equivalent to 10/15. And the second one, the 2/5, is really equivalent to 6/15. So equal sign there. I'm going to build a rectangle that's exactly the same size. And now we just have to put all those circles in one because it's adding, not subtracting, it's adding. So I got 10 of those. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 from the first one. And then I have 6 from the second one. 1, 2, 3, 4, 5. Uh-oh, I filled it up and I still need a place to put one last square or circle. If this happens to you, that means you have more than one hole. So, build another rectangle that's exactly the same size and then keep filling away. Well, we only have to put one more in there. 1. And what this means is that you have one whole thing, the number 1, and you have a little extra, 1 whole and 1/15. So what you would say in your answers, you have 1 and 1/15. That problem took a little bit more thought, but I think you got it. Keep practicing. If you have any help, just ask your teacher.